Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us now begin solving this step by step. BF3 is a Lewis acid, electrophile, because boron has an empty p orbital and only 6 electrons around it, making it electron deficient. Acetone is a Lewis base, nucleophile, because oxygen has lone pairs, non-bonding electron pairs, that can be donated. Moving on to the next step. The HOMO is the highest occupied molecular orbital that acts as the nucleophile. In this Lewis acid-base interaction, the nucleophile is acetone acting through its oxygen atom. The lone pairs, non-bonding electron pair orbitals, on the oxygen of acetone constitute the HOMO that donates electron density to BF3. Options A is wrong because boron in BF3 has no non-bonding orbital with electrons, it is electron deficient. Option B, sigma orbital of acetone is not the donor orbital in this reaction. Option C, pi orbital of acetone could in principle act as a nucleophile, but the non-bonding lone pair on oxygen is higher in energy, better HOMO, and more accessible for donation to Lewis acids. Therefore, answer A is equal to D, non-bonding electron pair orbital on oxygen. Moving on to the next step. The LUMO is the lowest unoccupied molecular orbital that acts as the electrophile. BF3 has an empty p orbital on boron, perpendicular to the plane of the 3 BF bonds, which is the LUMO that accepts the electron pair from oxygen. Option B, sigma orbital of BF3 is occupied. Option C, pi asterisk of acetone is unoccupied but it is not the primary electrophilic site in this reaction, BF3 is the electrophile. Option D, non-bonding orbital on oxygen is occupied. Therefore, answer B is equal to A, p orbital of BF3. And for the final step. When the lone pair on oxygen of acetone donates into the empty p orbital of BF3, a coordinate, dative, bond forms between O and B. Oxygen donates 2 electrons to boron, so oxygen becomes positively charged, O+, and boron acquires a negative formal charge, BF3. The acetone skeleton is preserved, CH3 groups remain, carbonyl carbon remains sp2. This gives the product CH3 to C is equal to O plus dash BF3 dash, which corresponds to option A. Option B shows O with a negative charge, which is incorrect. Oxygen donates electrons so it becomes positive. Option C shows a different carbon skeleton inconsistent with acetone. Option D shows BF3 bonded directly to carbon with negative oxygen, which would require breaking the C is equal to O pi bond and is not the primary product of Lewis acid-base adduct formation. Therefore, answer C is equal to A. Therefore, the correct answer is A, D, B, A, C, A. Therefore, the correct matching is A matches D, B matches A, C matches A.